Hello, this is Mrs. Plenda, and today we're going to talk about simplifying algebraic expressions. Now, one of the things that we always want to know when we're learning something new is, why are we learning it? So why do you think we should be learning how to simplify algebraic expressions? Well, the easiest answer is to say I want to take something complicated and I want to be able to turn that into something less complicated, easier to work with, right? So that's the main reason that we're going to simplify algebraic expressions, to make them easier, simpler to work with, so that it's not quite so much of a mess when we go on to do something else, like solving, which we'll do later. So there's going to be two main ways that we're going to simplify algebraic expressions. The first way is that we're going to combine like terms. We're going to talk about that in a second. Our second way is that we're going to deal with groups. Remember when we talked about our order of operations, groups can mean parentheses, can mean other things. When we talk about it today, it will mostly be parentheses is going to be the group that we're going to talk about today. So let's zoom in on this combining like terms and talk about that first. So what are like terms? We need to know what they are first before we could do something with them. So like terms are phrases of variables and constants and variables that have exactly the same variable, so the same letter, with exactly the same exponent. So let me give you a couple examples. So if I have something that looks like 2x, right? I've got a letter, I've got a number. What about 4x? Different numbers, but the same letters. So it's the letter, the variable, that is the important part that has to be the same. In this case, they both have x's. So that means that 2x and 4x are like terms. But if I have something that looks like 4x squared, this is not a like term because it doesn't have the same exponent as the first two x's that we already talked about. Okay, so this one would not be a like term because it doesn't have the same exponent. So that's what we're looking for when we're talking about like terms. They must have the same letter and they must have the exact same exponent. So let's take a look at this first example. I have 1 plus 2m plus m, and we're going to look for like terms. So I see that I have an m here and an m here, same letter, same exponent. I don't see one. So that means that these are like terms and I can go ahead and add them together. But how do I add just m to 2m? How does that work? So one thing that you want to think about, if you don't see a number in front of a letter, how many do you see there? Like how many m's do I see in that second spot? Well, I just see one. And that's always what the number is going to be if I don't see a number in front of it. So what this actually means is that I have 2m plus 1m, because there's just one little m sitting there. So 2m plus 1m are like terms I can combine by adding. 2m plus 1m will give me 3m. And of course, we still have the 1 in the front that we need to bring down. So I have now combined the like terms there, and we can see we have a simpler phrase than what we started with, right? Like there's less of it. It's going to be easier to work with later. Okay, so that's combining like terms. Let's do another example. Now for this one, I have a couple of different like terms. I have, well, let's see if I can find my spotlight here. I have a number and another number, and then I have some letters that are exactly the same. So the letters are going to be like terms and the numbers are going to be like terms, but those guys are not right next to each other. So we want to be thinking, what can I do to put those right next to each other? And the good news is, like when we talked about our order of operations, we can add and subtract in any order. So I can take this phrase and I can rearrange it and move the pieces so that the like terms are next to each other, so that then I can go ahead and combine them. So now I've got my numbers next to each other. 1 minus 10 will give me -9. And then I've got my letters next to each other, my r's. So 9r plus 2r is going to give me 11r. And now I have a phrase that looks smaller and simpler than what I had before, right? We have simplified this expression by combining our like terms, and now I only have two pieces that I need to work with instead of the four that we started with. Okay, so let's go ahead and talk about dealing with groups. Now, the way that we're going to deal with groups is with the distributive property, and you guys have probably talked about the distributive property before. I bet you know what it is already. So before, when you've talked about the distributive property, it has probably looked like this, right? Where they tell you, hey, if you have a number multiplying on the outside, you can actually multiply it to each number on the inside and get the same thing. So just to make sure that this works the way that it's supposed to, let's go ahead and simplify each side of this equal sign, right? Let's make sure it's really equal. So following my order of operations, I would take this 2 plus 5, and I would normally do that first because that's the group. So I'm going to go ahead and add those. 2 plus 5 gives me 7, and then I still have that 4 multiplying on the outside. Well, 4 times 7 gives me 28. All right, so that's a good start. Let's take a look at the second side and see if that's actually going to give me the same thing using the distributive property. So the distributive property says I can multiply the 4 with the 2 and then the 5 and then add that together and get the same thing. Let's check. 4 times 2 gives me 8 and 4 times 5 gives me 20. Well, what do you know? 8 plus 20 is 28. Those are in fact equal, okay? So we can see that the distributive property definitely does work. But there's no reason to use it if I can just add those numbers in the first place. Why would I ever, do the extra step of multiplying each step and then adding, right? That's an extra step. Okay, well, we're in algebra now, right? So there will be times when I cannot add that piece that's inside the parentheses, right? Once I throw an X on one and not on the other, now they're not like terms. And I can't combine them. So I can't follow my order of operations because they're not like terms inside of the parentheses there. So I have to distribute. So I will take the 2 and multiply it with the 1. That's what we have over here. 2 times 1 is 2. And I will take the 2 and I will multiply it with the 4x. And that's where we have negative 8x. And you can see that using the distributive property lets me get rid of those parentheses. And everything is simpler once you get rid of parentheses. Okay, let's take a look at another example. Ooh, this one's putting everything together. I've got parentheses and probably, I'm going to have like terms later. So let's deal with the parentheses first, just like we would in our order of operations. I cannot go ahead and add those pieces inside the parentheses together because they are not like terms. But I can distribute to get rid of those parentheses. So 6 times a will give me 6a, and 6 times negative 4 will give me negative 24. And we still have the plus 7 on the outside. It didn't go away, we just haven't done anything with it yet. So that's what we're going to do in the next step, because again, we're looking for those like terms that I want to take care of if I can. So I don't have any like terms to go with the 6a, so I'm just going to rewrite the 6a. But the negative 24 and the 7 are just numbers, and numbers are always like terms. Constants will always be like terms with each other. So negative 24 plus 7 will give me negative 17. And you can see we have a much smaller, simpler phrase now than what we started with. And that would be an easier problem to solve than if we started up here at the top, right? That's bigger and more complicated and looks harder, right? So we simplify first, and then we move on to do other things like solving or graphing and things like that. So let's do another example. All right, now, one thing that I want to talk about here, and I chose this example on purpose, is I want to talk about this negative. Because remember, when we talked about our order of operations, I said that sign has to stay attached to the number behind it. And in this case, this means when I distribute that 4, it's not just 4 I'm distributing, it's going to be negative 4. So I need to think negative 4 times 2b, and that's going to give me negative 8b. And I need to think negative 4 times 5, and that's going to give me negative 20. And we have to be double careful because this second step is where I usually see students make mistakes. We want to make sure that we're distributing that negative 4 to both pieces, because if we didn't distribute and we were adding, whatever sum we got in the middle of those parentheses there, that whole sum would be multiplied by negative 4. So it's the negative 4 that we have to multiply by each piece when we're doing that. Okay. Now don't forget, we still have this 9b. We didn't do anything with it. We need to bring it down. Okay. Now, do I have some like terms that I can put together? Absolutely. I see that I have a b here and a b here. That means that I can go ahead and add those together. So 9b minus 8b is going to give me 1b. And nothing happened to the negative 20. It's still there. But you notice 1b minus 20 is smaller and simpler, and it's going to be much easier to work with than what we started with, right? So we're going to practice this a little bit before we move on to our next steps of solving, but we want to make sure that we can simplify and do this very well before we move on to the next thing. So let's practice this a bit.